So lesson 2-5 is over scatter plots and lines of regression. So what we need to remember from Algebra 1, first of all, what we need to remember is different types of correlations. So in our scatter plots, you'll see a trend to the points. And sometimes there's a weak correlation where the points aren't there. You can tell that they have a negative correlation, but they're a little bit spread out. If they're really close together, then it would be a stronger correlation. If the points are rising from left to right, that would be positive. A line of best fit would have a positive slope. If they're decreasing, it would be a negative slope. You may have a few outliers. Even with a strong positive correlation, you could have some outliers. Sometimes there will be no correlation to the data. You can't tell if it's a positive, negative, just they're very spread out, and it's hard to see a pattern. This table shows the approximate number of students who sent applications to 2 colleges in various years since 1985. And we're going to make a scatter plot of the data, and we're going to try to create a line of best fit based on that data. We're going to have our calculator do as much of it as we can. And we're going to try to describe what type of correlation it is. So years since 1985. So if we have a 0 years since 1985 is 1985. 20% of the students sent applications to 2 colleges. This would be 1988, 18%. 1991, 6 years since 1985, 15%. 9 years since 1985 would be 1994, another 15%. 12 years would be 1997. So 1997, there would be 14%, and then it's decreasing some more by the year 2000, 13%. So if we graph the data on a chart and we let the number of years since 1985 be along our x-axis and the percent of students at that point be along the y-axis, then our scatter plot looks something like this. There's 1985, there's 1988, there's 1991, there's 1994, there's 1997, and then there's the year 2000. So if we pick 2 points that represent the data pretty well, like 318 and 1513, we use these 2 points to create a line of best fit. Then what we can do is draw a line through those 2 points, and we have a pretty good trend to the data, and we can use that line to make predictions. So we want to write the equation to that line. We use those 2 points, the coordinates of them, use our slope formula, put the numbers in, there's our slope, then use our point slope form, substitute in the point 318, that was one of the points we had, and the slope, negative 5 over 12, and then we simplify, distribute, simplify, and we come up with a prediction equation of y equals negative 15 over 12x plus 19.25. We can use that equation to predict how many students we think will send applications to 2 colleges in the year 2010. I know we're talking about the past, but if it was the year 2000 right now, we could predict how many we think would send, what percent of students would send 10 years from now. And all we would need to do is, since 2010 is 25 years after 1985, we put 25 in for x. And we get 8.83. So we would estimate that about 8.83% would send applications to 2 colleges in the year 2010. How accurate is that? Well, based on the data, only the .615, except for the .615, the rest of the points lie on that line very, very closely. So we think that this would be an accurate prediction. Now we're going to look at approximate percent of drivers who wear seatbelts. Various years since 1994, so this would be 1994, 1997, year 2000, year 2003, year 2006, and the percentages are steadily increasing. So the percentages of people who wear seatbelts is steadily increasing, so that's a good thing if we're looking at this data. But which one of these shows the best line of, or a good line of best fit for this data? I think it's pretty obvious. C goes through the middle of the points and follows the trend of the data a lot better than A, B, or D. So this is a pretty common sense answer. But when we look at the equation of that line, how can we create the equation for this line? We can use 2 of the points that are actually on that line, the 671 and the 1281. We use those points to come up with the slope. Use the slope formula again. 81 minus 71 over 12 minus 6. Simplify that to come up with the slope. We look over here at our answer choices. We've got B and D both having negative slopes. We can eliminate those choices right away. So whatever we get, 81 minus 71 over 12 minus 6, that would be either 3/5 or 5/3. If you do it right, you should get 5/3. If you do the wrong ones on top, you get the wrong answer. So we can use this equation, 5/3 x plus 61, and we maybe want to predict, well, what's it going to be in 2010? So we would need to plug in, if x is the number of years since 1994, we would plug in 16 for x. And then simplify. 5/3 of 16 plus 61, you get 87. 87% is the predicted amount. How accurate are these predictions? Is there any outliers? Were there any outliers? Maybe a little bit off, a few outliers, but I wouldn't consider them to be extreme outliers. I think they say there's one outlier. I don't agree. I don't think there's any outliers. I think it fits the data well. To me, an outlier is an extremely off the beaten path scatter plot. But either way. All right, this shows the median income of U.S. families from 1970 to 2002. So in 1970, the median income was about $10,000. In 1980, $21,000. 1985, $27,000. 1990, $1995, 1998, 2000, 2002, the median income was $51,680. So it's steadily increasing. So this should have a positive slope, positive correlation. We want to figure out we want to make a prediction of what's going to happen in 2015. What we can do is let our calculator do a little bit of the work. And if you've forgotten how to use your calculator for this, then you may need to, I'm sure there's a few of you that remember, and try to share your knowledge and with the rest of the group, and let's all get this figured out today. But you go to your calculator, go to list 1 and list 2, and you'll put in the data and use the stat plot to create a graph. Now you're going to have to change your window a little bit so that it only shows the area that we want it to focus on. But we can use the list 1 and list 2, and we can use linear regression, which you get to using stat and calc on your calculator, and linear regression, and it'll give you an equation for a line of best fit through that set of points. So if you'll go ahead and do that now and put in your numbers into list 1 and list 2, create the scatter plot, make your window fit the data well, and then come up with a linear regression equation. The equation you should get is 1,349.87 x minus 2,650,768.34. Well, the slope here indicates this 1,349.87, which is about 1,350. It indicates that the income is increasing at about that much, at a rate of about 1,350 people per year. Actually, I think this is supposed to read $1,350 per year. Not sure why it says people. Another error, I believe. Maybe I'm misreading it. It looks like another error on the part of the book. It also, sometimes you can get an R value, and that tells you the strength of this equation. It gives you a R value of about 0.997. 1 is perfect, so 0.997 is very close. So we would say that this fits the trend fits the regression line. The data fits the regression line very well. We want to next graph that equation on top of our data in StatPlot. So we created the window, and then we want to put that equation into y equals and graph them both at the same time, and it'll slowly draw that line, or may not. It'll show you that the line goes through this data real well. Now the next thing we want to do is try to predict what is going to happen in 2015. So we can either it says use value on the calc menu. I'm not familiar with using value on the calc menu. Maybe some of you are. I might send you to the table for that equation and let you go down until you find X of 2015, or change and start the table at 2015 and go from there. But either way, the income, if you use that equation, it should come out to around 69,220. This shows winning times for an annual dirt bike race from 2000 to 2008. Again, use your calculator to make a scatter plot of the data. List 1 and list 2. Put the years in list 1, put the times in list 2. Then do stat calc and let it find the line of best fit using linear regression, and then take that equation, plug it back in, and let it draw that line through your scatter plot. Then you can go to the table or you can do the value command and try to predict, use that equation to predict what it's going to be out around 2015. So I'll let you work on that. Pause the video now, see if you can come up with the right answer, and then when you've got it, when everybody's got an answer, you can agree on an answer, then you can continue to play this video and see what it is. Hopefully you've got the equation now and you're able to see the answer, come up with an answer choice, I haven't verified it. They say that the answer is B. I hope they're right. Anyway, your main job is to figure out and relearn how to put things in the calculator for linear regression and set up the window and things like that. And then the worksheet that you've got, that'll be due on Tuesday. All right, we'll see everyone Monday.